Now we're going to look at some features of the dienophile in the reaction. So remember that the dienophile is going to be this structure here, which is a pi bond, and it can have several substituents on it. The first thing is that this dienophile doesn't have to be an alkene. It can also be an alkyne. So if we look at this above reaction, let me highlight the alkene in blue. When you do the reaction, we get cyclohexene. And here are the two carbons that were the alkene of the dienophile. If that instead is an alkyne, let's look at what happens. We still get the cyclohexene framework. But like above, when we went from a double bond to a single bond, if the dienophile is an alkyne, you go from a triple bond to a double bond. So in the product, we'll have a double bond. The second thing has to do with the reaction rate. And we talked about electron donating and withdrawing groups earlier. If you have electron withdrawing groups on the dienophile, that will accelerate the reaction. Let's look at a series of dienophiles in order of increasing reaction rate. So the slowest would just be ethylene. But then if we add some electron withdrawing group, maybe a fairly weak withdrawing group like a halogen, that'll make it a bit faster. Then if we want to increase the rate more, we could add, instead of a halogen, a stronger electron withdrawing group, maybe a nitro group. And then we could get an even faster rate if we have not one, but two nitro groups. And this would also hold true for the alkyne dienophile. So let's just do an example. And maybe for our diene, we'll have this. And for our dienophile, instead of just acetylene, what if we have a cyano group attached? That's going to make for a faster Diels-Alder reaction. So now, to predict the products, start with our cyclohexene, and then add the things we need. You can color code these like I've done before, or some people like to number them. There's carbons 1 through 4, and then 5 and 6, and then put in the appropriate groups. So we end up with an ethyl group at carbon 3. At carbon 6 is the cyano group. And don't forget, since our dienophile was a triple bond, we end up with a double bond between 5 and 6. So there's the product to that reaction.